Hello everyone, this video is also in continuation with my previous videos on polymorphism. In this video we will learn about virtual functions. It is a very important part of polymorphism portion of object-oriented programming. In object-oriented programming, a virtual function is a function whose behavior can be overridden. What are virtual functions? Virtual function is a member function of the class. It can be overridden in its derived class. And we can define virtual function by the virtual keyword. Virtual function call is resolved at runtime. Now let's look at the rules for virtual functions. Virtual functions cannot be static functions or friend function of another class. To achieve runtime polymorphism, virtual function should be accessed using pointer or reference of base class type. The prototype of virtual function should be same in both base class as well as in derived class, or in parent class and in derived class. Prototype means declaration of virtual function. They are always defined in base class, then overridden in derived class. So definition will be in base class and redefinition will be in derived class. And it is not mandatory for derived class to override the virtual function. In such case, base class version of function will be used. Now we will see one program based on virtual functions. This program is an example of virtual function. Here I am having one base class, the name of the class is base, and one derived class, publicly derived from this base class. The name of the child class is derived. I have defined one virtual function in the base class. The name of the function is print, and I am printing the message print base class in this void print virtual function. I have redefined this void print function in the derived class and printing the message print derived class. So there is no need to write virtual keyword again in the derived class. And here I am also having one show function in the base class as well as in the derived class. In the base class's show function, I am printing show base class, and in the derived class show function, I am printing the message show derived class. This show function is having same signature in both the classes, in the base class as well as in the derived class. Now let us look at the main function. Here in main function, I have taken one pointer of base class, pointer type variable of base class. Actually, runtime polymorphism is achieved only through a pointer of base class type. This base class pointer can point to the object of base class as well as to the object of derived class. And I have taken an object of derived class, and by this statement I am assigning the address of derived class to the BPTR, this pointer. So this BPTR base pointer contains address of the derived class. Now by the help of BPTR I am accessing print function as well as show function. Now let us execute this program. As you can see in the result, I am getting print derived class and show base class. Actually, late binding or runtime polymorphism is done according to the content of the pointer, and early binding or compile time polymorphism is done according to the type of pointer. So here this BPTR contains address of the derived class, and this print was a virtual function. So by the help of this statement, I can get message from the derived class. I can access print method of the derived class because this base pointer contains address of the derived class. But show was a non-virtual function. So we can access only the base class show function because this BPTR, the type of this base pointer was BPTR was base pointer. It is a pointer of base class. So this statement will give us output from the base class's show function. Now let us move back to our slides to know about virtual function. pure virtual function, we can also call it an abstract function. It's a virtual function for which we don't have any implementation. We only declare it. So we can declare a pure virtual function by using a pure specifier or equals to 0 in the declaration part of the virtual function. We can declare pure virtual function like this. Class name is AB, and if I'm declaring equals to 0 to this virtual function, then it will become a pure virtual function. Now let us look at the abstract class. An abstract class is a class which contains at least one pure virtual function. So one pure virtual function can be implemented by the class which are derived from an abstract class. So classes derived from the abstract class must implement the pure virtual function. Now let us look at the program. In this program, I am having one base class, shape is my base class, and two derived classes publicly derived from this shape class. Rectangle is my derived class and circle is my derived class, publicly derived from the shape class. So in this shape class, this shape is an abstract class. Why? Because it contains pure virtual function. There are two pure virtual function in shape class. Virtual void find area is equals to 0 because we have assigned 0 value to this pure virtual function. 0 is specifier, so this is a pure virtual function. Now in public section, I have defined one variable area of float type and two pure virtual function in shape class. So now it is must to override these two virtual function in the derived classes. So this rectangle is publicly derived from the shape class. Here I am taking two variable length and breadth of float type, and rectangle is my constructor, parameterized constructor of this derived class. I am passing two arguments of type float, float L, float B, and this constructor is used to assign the value to length and breadth. So I am assigning L to the length and B to the breadth. Here, as I have said, it is must to override these two pure virtual function. Find area is my pure virtual function and display detail. So it is must to override these two pure virtual function. So void find area, I am going to override it in my derived class. Area is equals to length into breadth. This find area will calculate area of the rectangle. And in the display details function, I am displaying all the details of rectangle, length, breadth and area. This was my one derived class. Now circle is my second derived class, publicly derived from the shape. So R is a variable, it is a private variable of this class, and in the public section, this is my constructor. Circle is my constructor, and as the parameter name is same, float R I am passing to this circle, and here also I have defined R as a parameter. So the name of the parameter is same, so I can access this R by this pointer. So this pointer R is equals to R. I can access the private variable of class by the help of this pointer. Now find area, I am going to override find area method. So here I am calculating area of a circle by this formula. We all know the formula for area of circle. Now in the display detail method, I am going to display all the detail of circle, radius and area. Now here is my main function. So it is must to take a object to take a pointer to the base class. So here this obj pointer is pointing to base class. Now rectangle was my derived class. I am taking an object R1 of rectangle, and I have taken parameterized constructor. So I am passing 2 parameters to this R1. Now by this statement, I am assigning address of R1 to obj. Now this obj contains address of the derived class rectangle. Now if I am accessing find area and display details method on this object, it will point to the rectangle object because this obj contains address of rectangle class. Here I am taking object C1 as an object of circle class and passing R. I am passing one parameter to this C1 as R, radius of the circle. Here I am assigning address of the circle class to this object. So now this obj pointer contains address of the circle class. So if I am going to access find area and display detail method on this object, it will point to the find area and display details of the circle. Now let us execute this program. You can see the output over here. Rectangle, length 2.3, width 4.5 and area 10.35 by these statement, and for circle 4.5, area is 63.585. This brings us to the end of this tutorial. Thank you for watching.